Hello, my name is Benjamin Busse. I work at IMEC. Today I want to demonstrate the demonstration which is demonstrating the paper number 26.6. Why do we use ultra-wideband for the around the head and around the body communication? So there are key features which are used for this. So first of all, we have a very small antenna. We are resilient against fading, narrowband fadings. We can be able to do duty cycle both the transmitter and the receiver on a bit level, which reduces power consumption. And we are scalable in data rates and also in power consumption. So how does the architecture look like? We have a transmitter and a receiver setup. The transmitter is a complete integrated chipset. It contains the digital baseband and the analog front end. On the receiver side, we have the analog front end as a separate chip, the A to D converter as a separate chip, and the digital baseband, which is mapped on a FPGA platform. What are the highlights of our architecture? For the transmitter, we have an injection-locked power amplifier, which is capable of transmitting an output power of -3 dBm. We have a DCO, which we can tune with steps of 1 megahertz. And we have on the receiver side an ASIC and an ASIP in combination with an ASIP. So this makes it very flexible for us. If you look at the system implementation, you can see the die photos of the transmitter. So the transmitter again is integrated baseband and analog front end. The receiver front end is a separate chip, and the A to D converter is also separate. What you see here on the table is a complete setup. So we have on one side the transmitter, on the other side a receiver. Currently we are transmitting audio song from the transmitter to the receiver set, and we do that at the 8 gigahertz band. This band is worldwide available and can be used in the whole world. This is the first worldwide available transmitter receiver set which is capable of transmitting a streaming audio link. So if we look at the setup, we first have the transmitter box. In here, the key component is the chip. It's the dot on the PCB. This one is fed by the PC with information which is transmitted via this differential antenna. It is transmitted to the other side of the table, and here it's received by the analog front end. It's then converted to the digital domain by the A to D converters, and the synchronization algorithms and payload decoding is done on the FPGA, which is the baseband. The information is then transmitted to the PC, where some key information is showed on this plot. And also, if we put the microphone, we can hear the music, which is transmitted over this link. So to summarize, this is the first ultra-wideband system which is capable of transmitting an audio stream over a distance, a longer distance than 10 meters. The second thing is we can transmit from ear to ear. And the third thing is we can also use ultra-wideband for localization purpose, for indoor localization. And this makes ultra-wideband a suitable candidate for this application area.